We have a quick overview of what the website is all about, so we might go on to that one, because every time I start talking, we start losing viewers, which is interesting.
Okay, think about this. How do you take really, really complex technical information, the kind that feels like you need a PhD just to read the first page? And how do you make that not just understandable, but actually engaging, maybe even fun? That's exactly what we're exploring in this deep dive. We're looking at a platform, BioniChaos. It seems to be doing something pretty cool with how we handle dense biomedical data, tech, and even education. It's not just about learning facts, it's more about finding new ways to, play with knowledge, making it genuinely enjoyable.
Exactly. And what's really striking here, I think, is the move away from just, static things like PDFs or textbooks. Instead, imagine dynamic simulations, visual tools where you can actually see what's happening, where you can manipulate complex biomedical ideas, explore them. It makes abstract concepts feel almost
real,
tangible, like a digital sandbox, really.
Right, a sandbox. I like that. Okay, let's dig into an example. Fourier Series. Anyone who's wrestled with that math, trying to picture how complex signals break down into simple wave, it's notoriously tough. But BioniChaos has this high-fidelity Fourier simulation. You literally watch signals in the time domain decompose into frequencies. You see those epicycles, those basic circles building up complex shapes happening right there. It's such an immediate aha moment for understanding signal composition. Super important for diagnostics, too.
It absolutely is. It's a completely different way to get your head around signal decomposition. A huge shift. And then building on that, think about their interactive guide to EEG tech, trying to grasp the differences between, say, delta, theta, alpha, beta brainwaves just from a book. It could be so abstract. But with this tool, you can manipulate the parameters and actually see how these different brainwave patterns show up. It makes their clinical meaning much more obvious, much faster. You're visualizing electrode placement, exploring brain states directly. It's very hands-on.
That hands-on part feels key, doesn't it? And it's not just for brainwaves, right? This idea of visualizing signals works elsewhere too. They've got an ECG simulator, so you can mess around with different heart rhythms, tweak electrophysiological settings, and you instantly see how that changes the ECG waveform. It gives you this unique insight into how heart conditions actually affect the electrical signals. It really is like having a virtual heart lab on your screen. You can understand the mechanics without any risk involved. Pretty amazing.
It's definitely a powerful way to learn, to really master complex physiological systems, because you're interacting with them, not just reading about them and, even just dealing with massive amounts of information. That can be overwhelming. But their multimodal medical data landscape tool, it lets you explore diverse data sets interactively. You can see where the data gaps are, figure out ways to connect different types of information. That's so crucial for developing new health tech. It sort of turns data analysis from a chore into more of an engaging exploration, finding the fun of discovery again.
So pulling this all together then, what we've seen in this deep dive is just how powerful these kinds of interactive tools can be. They take really intricate subjects, signal processing, brainwaves, heart rhythms, navigating huge data sets, and make them feel intuitive, almost like a game. It feels like a shortcut to truly understanding things, sparking those aha moments that actually make learning stick, make it exciting.
Indeed. It really underscores that knowledge isn't just something you absorb passively. The real value comes when you actively explore it, play with it, understand it deeply. So here's something to think about, a final thought maybe. How could this approach to learning, the one emphasizing visualization, simulation, real-time interaction, how could that change how we understand any complex field, not just biomedicine? Imagine tackling complex engineering or physics or even art history by interacting with it, by essentially playing with the core concepts, making deep knowledge accessible and maybe even thrilling for everyone.
Everything we do is available freely on bionichaos.com. Please consider supporting me on Patreon, and don't forget to click like, subscribe, and comment.